Hello everyone. Today we'll be discussing about DC lap winding diagram. So in this session we are going to learn about how to develop a DC lap winding diagram. So before going with that, let us understand about some construction features of DC machines. So as we know, there are two major parts we have in DC machine. One is stator part and another one is rotor. So actually here in DC machine, the conductor cuts the magnetic flux and an EMF gets induced into that conductor, and all the induced current will be collected by commutator and brushes. So in this winding diagram we are going to represent a conductors and how the conductors are interconnected and how these turns are connected to the commutator and then the brushes. This is what we are going to represent in this DC lap winding diagram. Okay. So before going with the core topic of today's session, let us understand about some basic terminologies regarding conductor, turns, pole pitch, and so on. So here you can see this in this diagram. In this diagram, you can see that here we have a slots and there is a conductor inside a slot. This is nothing but your coil side 1. See, the conductors are usually placed within the slots, and here if you connect one conductor in one slot with another conductor which is placed in the other slot, then it will forms singleton coil. So it means if you want to have a singleton, you're supposed to have one and conductor 2. If you have two conductors, you can get one singleton coil. Likewise, we have a multi-turns coils also. We have a multi-turn coils, right? A coil side and then multi-turn coil, singleton coil and then multi-turn coil. Remember, a coil conductor in one slot, if it is connected to the conductor which is placed in the other slot, then it will form a turn. So now the next portion is to calculate, find out about pole pitch. What do you mean by pole pitch? So there are different way of defining the pole pitch. Pole pitch can be defined in terms of distance. So if I define in terms of distance, the radial distance between two adjacent poles. This is a pole and this is the another pole. The radial distance between these two poles is nothing but your pole pitch. In the other way, in terms of slots, the number of slots, distance between the poles in terms of slots is called also pole pitch. It is also called as what? A pole pitch. Okay. Now, see, as I already said, the conductors are usually placed within the slots. See, here in this figure, we'll be having only one conductor in each slot. That's why it is called single layer. Therefore, the coil side is equals to what? 1. And here in each slot we are having two conductors. That's why the coil side is equals to 2, and this type of arrangement is called what? A double layer. And here also you can see that we'll be having 4 conductors in a single slot. That's why the coil side is equals to 4. So how to represent these in your AutoCAD drawing, right? See, for example, if I take a single layer, all the conductors are visible here because I have only one conductor in each slot. It means all the conductors are visible. So this visible conductors are used to represent by using a continuous line. This is how we can represent an visible conductor. Let us discuss about double layer. In this double layer, there are two conductors. So the conductor 1 is visible, the conductor 2 is invisible. So the visible conductor, as I already said, it is used to represent by using a continuous line. But the conductor 2, it is an invisible line which is used to represent by using a dashed line or a dotted line. So it means a visible conductor is represented by using a vertical or continuous line, and invisible conductor are represented by using a dashed line, right? And here the number of slots and number of coil sides, if you know these two, then you can easily find out what is the total number of conductors present in the machines, that is represented by Z. So total number of conductor is equals to number of slots into number of coil sides. Okay, for example, if you have 10 slots and the coil side is equals to 1, then the number of conductor is also equals 10 into 1 is equals to 10, right? For example, if it is a double layer and the number of slots is 10 into 2, then the number of conductors will be 20. Now the next question is how to interconnect the windings, how to interconnect the conductors. See, for example, this is the conductor 1 and this is the conductor 2 and this is the conductor 3 and this is the conductor 4. For example, here the first conductor is connected to the third conductor at the back end, it means the top end. The first conductor is connected to the third conductor at the top end. So why it has to be connected with the third conductor? That will be defined by the value of YB. YB is nothing but your what it is called, sorry, YB here it is called back pitch. So the value of back pitch will define the which conductor should be connected to the which conductor at the top end. And at the same time, this conductor number 3 is connected with conductor number 2 at the bottom end. That will be defined by using the front pitch. So the back pitch is YB and the front pitch is what? YF. So the top end connections will be defined by the back pitch value and the bottom end connections will be defined by the front pitch value. This is what YB is back pitch and YF is what? A front pitch. You can see here, and this is lap winding. What is that lap? For example, 1 and then 3 will connect it together to form one turn. Conductor 2 and then conductor 4 will are interconnected to form another turn, right? So the terminating end of one turn is connected to the starting end of the other turn through a commutator. This is what your commutator. Okay, this is what your commutator. Okay, this is the commutator. It is connected through this. This is called what? Lap winding. And wave winding, it will be in this fashion. Yeah. Now commutator segments. So here I already said here I have a commutators. How many commutators we supposed to have in a lap winding or in case of wave winding? So the number of commutator segments should be equals to NL into M. NL is nothing but your slots, right? NL is nothing but your slots, and M is equals to what? A coil side, right? Whether it may be 1 in case of single layer, it is equals to 2 for double layer, right? So this is nothing but your total number of armature conductors Z. So commutator pitch YC. So the commutator pitch is represented by using YC. It is the distance measured in commutator segment between two ends of the coil. This is what from ear to ear, this is commutator pitch, and here from ear to ear, this is what a commutator pitch. Okay. With this knowledge, let us go for develop a lap winding diagram. See, if you want to develop a lap winding diagram, we supposed to go through 4 different steps. In the first step, we need to calculate all the pitches. It is nothing but a pitch calculations. We need to calculate the pitches. We will be calculating 4 pitches: pole pitch, then back pitch, front pitch, commutator pitch. So we are going to calculate all the 4 pitches in step 1. That is what we are going to discuss now. So you take any problem, the number of slots, the number of coil sides and the number of poles are the given data. These 3 are the given data. So number of slots is represented by NL, number of coil sides per slot is represented by M, and number of poles is represented by P. So let us have an example here. Let be slots is equals to 17 and coil side per slot is equals to 2. It means it is a double layer, right? It is a double layer, and number of poles is equals to 4. Now total number of conductors, so I need to calculate this total number of conductors. Z is equals to NL into M. 17 into 2, it will give us what? 34. So total number of conductors are what? 34. We have 34 number of conductors, right? So the pole pitch in terms of conductor, so it means the pole pitch in terms of conductor. So I have 4 poles. So in a single pole, how many conductors are there? That is what pole pitch. Yp is equals to Z by P. So 34 divided by 4, it is 8.5. But here I should not take the pole pitch as a fraction. So I need to modify this. I need to modify the pole pitch value. That's why I have rounded it off to a lower integer 8. So then the modified and the final pole pitch value is what? 8. Okay. This is pole pitch is equals to 8, and the commutator pitch, the YC is equals to X, where X depends upon the type of the winding. 1 for simplex, 2 for duplex, 3 for triplex, 4 for quadruplex. So for this example, let us take it is a simplex winding, therefore X is equals to 1. So for this problem, number of coil side per slot is 2 and X is equals to 1. It means it is a double layer simplex lap winding. That's it. Double layer because of 2, and it is simplex because the value of X is equals to 1, right? Double layer simplex lap winding. So now I need to calculate back pitch and then the front pitch. So in order to calculate back pitch and then front pitch, I will be having 2 equations. YB plus YF is equals to 2YP. YB minus YF is equals to plus or minus 2YC, right? So if you solve these 2 equations, you are going to have 9 as a back pitch value and 7 as a front pitch value, right? So YB is equals to 9, YF is equals to 7, and here we have plus or minus 2YC. Here plus for progressive lap winding. If the lap winding is progressive in nature, then it is plus. If it is retrogressive, then it should be considered as a negative, minus 2YC. Okay, so here no need to modify the value of back pitch and then front pitch. So these 2 should be an odd integers. These 2 should be an odd integer. For example, if you get 10, YB is equals to 10, YF is equals to 18 in some cases, then it has to be modified to 9 and then 7. Yeah. So if the values of YB and YF are even, then the next lower values of odd integer for both YB and YF are selected. This is what the final back pitch value and the front pitch value is 9 and then 7. Okay. Okay, the step 2 is about winding table. Step 2 is about winding table, back end connections and then front end connections. So now I have already calculated YB is equals to 9, YF is equals to 7. Okay, so now let us go for winding table. So 1 plus YB is equals to 10. This is what YB. Okay, 1 plus 9 is equals to 10. This 10 minus 7 is equals to 3, and this 3 plus 9 is equals to 12, and 12 minus 7 is equals to 5, and so on. So for example, here I have total maximum number of conductors or 34 in this problem, because 17 slots and it is a double layer. 17 into 2, it is 34. But in this process I got 27 plus 9 is equals to 36. So 36 means what? 36 minus total number of conductors, that is 34, is equals to 2. 36th conductor is nothing but the conductor number 2. Okay, likewise here 29 plus 9, it is 38. So again 38 minus 34. Why 34? Because I have only 34 conductors. 38 minus 34 is equals to 4. It is nothing but it is fourth conductor, and so on. So how long I need to write this winding table? Till you get 1 at the front end connection. Till you get 1 at the front end connection. Clear? So for example, here I got 35. 35 minus 34. Why 34? As I already said, have only 34 conductor. 35 minus 34 is equals to 1. So when you get 1 at the front end side, then you can stop writing the winding table. Clear? Clear? Right. Now this is what the second step, the winding table. So from this winding table, what we can get is the first conductor is connected to the 10th conductor. For example, here I will be having like this. Sorry, 1, 2, 3, 4, etc., etc., and 10. This is the first conductor, and this is the 10th conductor. The first conductor is connected to the 10th conductor. Okay, the first conductor is connected to the 10th conductor at the top end, because the YB, the value of YB defines 1 plus 9 is equals to 10. 1 plus 9 is equals to 10. This is top end. And 10th conductor, this is what your conductor number 3. The 10th conductor is connected to conductor number 3 at the front end. As I already said, front end is nothing but your bottom connection. Okay, the front end is nothing but your bottom connection. Okay, sorry. So third conductor is connected to the 10th conductor. Here you can see in detail. So the first conductor is connected. So this is not a problem. Sorry. Okay, this is what your winding table. So let us discuss in detail about the lap winding diagram by taking an example. So in this example, draw the developed DC lap winding diagram for the following data. So number of slots are given, it is 16. Number of poles are given, 4. And the type of the winding, it is single layer and simplex lap winding. Okay, single layer means the coil side is equals to 1. It means M is equals to 1. And simplex, if it is simplex, means the value of X is equals to 1, because we know that YEC is equals to X, right? So the value of X is equals to 1. So total number of conductors is nothing but total number of conductors, that is Z. Okay, this is Z is equals to number of slots into what? Coil side. So M is coil side. Since it is single layer, so the value of M is equals to what? 1. Okay, and number of slots are 16, therefore Z is equals to 16. Number of poles are 4, therefore the pole pitch Z by P, it is 4. Okay, 4 conductor will come under each pole. Now next is to calculate back pitch and then front pitch. So the first equation, YB plus YF is equals to 2YP, that is nothing but your 8, and the other equation is equals to YB minus YF is equals to 2. The equation is what? YB minus YF is equals to plus or minus 2YC. They have not given any data regarding whether it is progressive or retrogressive. That's why let us consider it as a progressive. That's why it is plus. So YC is equals to X, where X is equals to 1 because it is a simplex lap winding. YB minus YF is equals to 2. If you solve these two equations, the value of back pitch is equals to 5 and the value of front pitch is equals to 3. And here no need to modify the value of YB and then YF. Why? Because I got odd integer. It is not an even integer. If it is an even integer, then I is supposed to modify that value, but now it is not required, right? The final value of back pitch is YB and the front pitch is equals to 3. The next step is to go for what? Winding table, right? So this is the back end connection, and then front end connection starts from the first conductor. I should start from the first conductor always. So 1 plus YB, so YB is equals to 5 is equals to 6, and 6 minus 3 is nothing but YF is equals to 3, and again 3 plus 5 is equals to 8, 8 minus 3 is equals to 5. So in this case the total number of conductors is 16, but here I got 18. So 18 minus 16 is equals to 2, and 20 minus 16 is equals to 4. So here I got 1, that's why I stopped writing the winding table. Clear? This is how you can calculate all the pitches: pole pitch, commutator pitch, back pitch, and then front pitch, and this is what the winding table. Clear? And this is what your winding diagram. Here you can see I have 16 conductors, so forget about this conductor. Okay, forget about this conductor. I have 16 conductor. The first conductor is connected to the sixth conductor. You remember 1 plus 5 is equals to 6. So 1, this 5 is just because of YB, right? So 1 plus 5 is equals to 6. The first conductor is connected to sixth conductor at the top end. This is due to what? This is due to what? YB. Okay, and at the same time 6 minus 3 is equals to 3. 6 minus 3 is equals to 3. At the bottom end, it means at the front end, it is connected, the sixth conductor is connected to the third conductor. Okay, likewise 3 plus 5 is 8, 5 plus 5 is equals to 10. Clear? So likewise, by using that winding table, you can interconnect the conductors. And the pole pitch, what the pole pitch I got? 4. YP is equals to 4. That's why this conductor will cover 4 conductors. Sorry, this pole, this north pole will cover what? 4 conductors. So that's why these 4, it means the first 4, 1, 2, 3, 4 conductors are under the north pole. If it is under the north pole, the current direction, it is towards commutator. You can observe here the current direction, it is towards the commutator. And the next 4 is under the south pole, and the current direction is what? The current direction is reversed. It means it is away from the commutator. Okay, again here towards the commutator, here it is away from the commutator, just because of the polarity north, south, and then south. If the conductors are under the north pole, the direction of the current is towards the commutator. This is what your commutator. Okay, and if it is under south pole, then the direction is away from the commutator. So now what about the number of commutator segments? The number of commutator segment is nothing but Z by 2, as I already said, right? Z by 2. I have 16 conductors, divided by 2, it is 8. So that 1, 2, 3, 4, 5, 6, 7, 8. I have 8. Don't name it as 9. Okay, it's just a cutting portion, right? I have 8 commutator segments. Now you connect all the turns to the commutator. Now how to place these brushes? For example, you take this commutator. What are the conductors are connected to this commutator? Just let me trace it. From here, it is connected to conductor number 1 and conductor number 4. You observe the direction of current of conductor number 1 and then conductor number 4. If it is in the both direction, I can place brush. Yes, the conductor number 1 and then conductor number 4 are having same direction of current. It means I can place the brushes in commutator 1. But what about the polarity? If the current is towards the commutator, then it is positive. Okay, next conductor number 2. You take commutator 2. Commutator 2 is connected to conductor number 3 and then conductor number 6. In conductor number 3, direction is downwards. 6, it is upward direction. It means I cannot place a brush in commutator 2. Next, commutator 3. Again go for conductor 5 and then conductor 8. Both are same direction but moving away from the commutator. That's why it is negative. So likewise this is also, and this also, and short positive and then positive, and negative and then negative. This is what your winding diagram. And in the next video, for the same example, I will be demonstrating how to draw a lap winding diagram in AutoCAD tool. I will be demonstrating that. Go through this video, and if you get any doubt, you can comment. Okay, thank you.